Welcome to this video. We're going to be talking about the circle of fifths and how that pairs with the odd harmonics. So, we can do a quick recap of, what each of those mean, in isolation. So the circle of fifths is when you have the C, G, D, A, E, B, right? It goes through all the sharps and the flats over on this and then completes with F and then you're back to C. So it's all 12 notes in order of, fifths in one direction and then fourths in the other direction. And then you can derive a lot of really interesting patterns. As far as the harmonic series, basically, when you take a string and divide it in half, you get the octave, you divide it into 3 equal parts and you get the fifth, hence the natural organization of the circle of fifths. If you divide it into 5, it's the major third at that point. Let's just remember that any even order harmonic is going to be some multiple, and that's something that you'd be able to hear. Say you were holding a guitar, if you go over the 12th fret, which is halfway across the string, it's the same note as what the string is tuned to open. So now I'm going to populate just the odd ordered harmonics, and I'm going to also annotate in the degree of sense how they are not perfectly aligned with equal temperament tuning. So this is actually going to be enlightening thing, hopefully, for people who are thinking about the difference between just intonation and equal temperament tuning, which is basically the note distance over 12, which is your tone scale, and then it's 2 raised to that fraction. These are both 12-tone tuning systems, I'll just say, but there's a lot of alternative tuning systems. The first harmonic is going to be the first C that we can hear. So if you look at scientific pitch, middle C is 256 because it's an even power of 2. So for example, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, and so it doubles every time, right? So powers of 2 double. Now the human hearing range goes from 20 hertz all the way to 20 kilohertz. We wouldn't be able to hear 16 hertz, but we would be able to hear 32 hertz. So this on the staff is about 5 lines, and then it's that space below 5 additional lines on the bass clef. And so that's the actual vibrating frequency number that we're going to use here. The second harmonic is going to be a full octave. So the third harmonic is G, which is a fifth. 2 cents sharper than equal tempered fifth. The fourth harmonic, that's another C, so we go to the fifth harmonic, is our major third. 14 cents flat. Oh no. So minus 14 cents. The sixth harmonic would be a full multiple of that third harmonic, right? Because that's a double of that, so that would be another G. Now let's look at the seventh harmonic. A D flat, 31 cents flat. 31 cents. That's our seventh harmonic. Our third harmonic. Third harmonic. That's the fifth harmonic. And here we are, the seventh harmonic. And we have the ninth harmonic. D natural, 4 cents sharp. And the 11th harmonic, G flat, 49 cents. So this is actually a quarter, the nearest thing to a quarter tone. And this is the 11th harmonic that is natural in vibratory motion in any, with any higher harmonic systems. So any vibrating string, any percussion instrument has the potential to have this kind of timbre, the contour of these higher order harmonics. Are you with me?
13th harmonic, A flat, 41 cents sharp. 15th, B natural, that is 12 cents flat. That was amazing. Fresh marker. So our 15th harmonic is 12 cents flat. Our 17th harmonic is C sharp. Wait, interesting. C sharp. That is 5 cents sharp. That's interesting.
So our 7th harmonic is a C sharp that's 31 cents flat, but our 17th harmonic is a C sharp that is 5 cents sharp. Very interesting.
19th harmonic is a D sharp, so an E flat, that is 2 cents flat. And that is about as far as I want to take this.
So I'm going to graphically recreate this, and I'm going to actually put that on the screen right now. All right, so now on the screen, we can see a graphical representation of our circle of fifths with all of the deviations from equal temperament. Now, the Harmonic Series is the backbone of just intonation, which means that any note intervals are as close as physically possible to the Harmonic Series that you get from a pure vibrating string. And we can take note of a few things here. So we've got C, G, D, A, E, major pentatonic scale. So you've got C, D, E, and then G and A, right? Now, if we look at the notes and compare that with, like the F sharp, -49 being the 11th harmonic, if we compare the D being 4 cents sharp compared to an equal tempered D, it's much more just inherent in harmonic motion. A lot of these scales that have become the main focus of Western music theory. This is all mathematically and physically determined. It doesn't matter where on the planet or on what planet you are on for harmonic motion to be governed by the same physical principles. These are more or less modern truths of modern physical sciences and mathematics. So it is really interesting when you hear individuals talk about how music theory is centered around some sort of particular history. I don't necessarily see it that way. The Japanese have plenty of pentatonic scales, and some of them are hemitonic and some of them are anhemitonic, whether or not they involve a semitone interval in the pentatonic scale. So for example, when we're looking at C, G, D, A, E, the notes of any of those, the notes that are as close as can be, are actually a whole step up from each other, right? C to D is a whole step. We don't have a C to C sharp. When we do look at the yo scale or the in scale, which are a couple of examples from Japanese pentatonic scales, the in scale is hemitonic, the yo scale is anhemitonic. So each of those systems are based on this harmonic series, which is derived from just pure physical harmonic motion. You can't escape this, whether you're on the moon, whether you're on Jupiter. And that's the beauty that really undermines the idea that Western music theory is a be-all, end-all description of the mechanics of music. It's just not. When I've ever learned music theory, I've never taken Western music theory to imply that it was that.